Hi viewers, hope you're fine. It's me, Zafar, and you're watching ChemscopeChemistry. As we have been discussing the periodicity of properties, or you can say periodic table, and the topic to be discussed here is our ionization. What is ionization energy? It's the amount of energy required to remove an electron from its outermost shell, or you can say valence shell. It's amount of the minimum amount of energy required to remove an electron from the outermost shell of a gaseous atom. Why we take gaseous atom, isolated gaseous atom? Because the atom affect each other, and so we take atom in gaseous state so that the effect of the other atom could be minimized, their repulsions or forces of attraction could be avoided. It's the minimum amount of energy that is required to remove an electron from the isolated gaseous atom is called ionization energy. For example, we talk about sodium. Sodium has 11 electrons, 2, 8 and 1. In the last shell it has 1 electron. If we are to remove this electron, we heat it and this electron is removed from the valence shell. Now we get sodium positive ion, and the energy required is called ionization energy. Its amount is 496 kilojoule per mole. You may understand here that it is the unit of ionization energy, that is kilojoule per mole. This is unit for ionization energy. What are its strands in a group or in a period? How ionization energy changes? We will see. I have written period 2 elements in which I will talk about sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine and argon. You'll see there is increase in proton number from left to right in each element. There are 11, 12, 13, 14, 15, 16, 17 and 18 protons. As the number of proton increases in the same shell, its nucleus, its size decreases, its size contracts by the increase of proton. Okay, when the size decreases, the force of attraction between the nucleus and valence shell electron increase. As a result, ionization energy increases. You will see here in a period from left to right, nuclear charge increases and atomic size decrease, so ionization energy increase. You know, atomic size decreases, removal of electron become difficult, so ionization energy increases in a period. While in a group from top to bottom, you will see there is increase in shell in each period. This is our in each period. In a group, when you move in a next period, there is increase of 1 shell. Increase of 1 shell, you mean increase in shielding effect. Shielding effect decreases ionization energy. So the electron is going, valence electron is going far from the nucleus. As a result, the removal of electron becomes easier. So we will conclude that from top to bottom in a group, ionization energy decreases due to increase in shell number and increase in you can say shielding effect. Now we will discuss some elements which has more ionization energy. Boron or carbon, they belong to the same period. Boron comes first and then comes carbon, atomic number 5 and 6. You know, there are more electron in the valence shell and more proton number, so removal of electron from carbon become difficult because its size is smaller. We will say that carbon has more ionization energy than boron. Now, which has more ionization energy, nitrogen or phosphorus? You know, they belong to group 5. They belong to group 5. First comes nitrogen and then comes phosphorus. It has 2 shells and it has 3 shells. 3 shell mean bigger size. Bigger size means removal of electron easier. So we will say nitrogen has greater ionization energy than phosphorus. Now we are to compare which has more ionization energy, either sodium or potassium. They belong to same group. Sodium comes first and then comes potassium. You know, sodium size, atomic size is smaller, so the removal of electron is a bit difficult. But in case of potassium, it has more shells than sodium. It means greater size and greater the shielding effect that decreases the ionization energy. So we will say sodium has more ionization energy than potassium. In the end, we conclude that ionization energy is the minimum amount of energy required to remove an electron from the isolated gaseous atom. And we will say in a period from left to right, ionization energy increases due to decrease in atomic size, and in a group from top to bottom, ionization energy decreases due to increase in atomic size, increase in shielding effect that decreases ionization energy, and the removal of electron become easier. Thank you for watching. Hope so you must have watched this video and must have learned something. Thank you for watching.